That will be due on Monday at 5 o'clock. And now here is the next announcement. What is something that you want more than anything right now? A break? I have good news. We're not going to have class on Monday. You're still going to have to watch some stuff, but we have no class on Monday. I am going with Byrne to take some study abroad students to Chicago to the embassies to help them get their visa, their student visas and stuff sorted out. So I am leaving on Sunday. I have been conscripted because I have a chauffeur's license. And so they need another extra person to potentially help drive the van. So that would be me. There we go. That would be me. And so I'm leaving on Sunday and I won't be back until Tuesday. So that means you don't have class. So after class today, I will be sending you a link to, I actually taught this class hybrid last year. So I will send you a link to finish up logic and reasoning. Now, we do still have a homework assignment that is due on the 22nd. We are going to talk about how to do that today. So you should be in pretty good shape to try your best with it. Remember too, it's only 10 points and it is the last homework assignment that we have. So a couple of other deadlines that I want you to be aware of since I've got you right now. I'm going to go ahead and open this up just to take a look at the syllabus and see what's coming up. I do believe we have our next writing assignment coming up pretty quick. So Monday, December 6th, last week of classes, our second writing assignment is due. So do keep that in mind. Our video projects are due on Wednesday, December 8th. We are going to show those in class and I'll bring treats. And then our final exam is optional. So if you did, I haven't graded the exams yet. I will probably not get those graded until Thanksgiving or during the break, since I will be in Chicago and I don't like the idea of taking work with me in case anything happens to my luggage. So because of that, I may not take them to grade, but I will have them done over the break for you. So if you did pretty well on all 3 quizzes or exams, guess what? You don't have to take the final, but the final is available to you. And if you want to take it, I will be doing a review session and we will have a study guide and you get to bring a cheat sheet with you. So you could actually fill out the entire study guide, bring it in with you for the final, and I would be okay with that. So do kind of keep that in mind. If you're thinking about taking the final, it is Monday, December 13th from 1 to 3 o'clock right here. So the same time that we normally have class, it's just 50 multiple choice questions. I will most likely be doing a Zoom review session the night before, okay? For those who want it. So as we get kind of closer, if you're thinking about taking the final, let me know, okay? All right, so we are starting a new section today. I think this is going to be the one that you like the least, not because of any other reason than talking about logic is hard to wrap your head around. So we are talking today about logic and reasoning. And then when we get back, we'll talk all about language. Reading, writing, speaking, all that good stuff. So this could probably be one of the trickier sections, and I'll kind of talk about why as we get there. And I gave you the notes in full. You're welcome. Merry early Christmas and happy Hanukkah. What? My birthday is always near Hanukkah, except this year. Hanukkah's really early this year, but usually my birthday kind of falls somewhere within Hanukkah, so it's always kind of in my head. All right, so when we are talking about logic and reasoning, the very first thing that we need to do is really talk about the difference between inductive reasoning and deductive reasoning. So inductive reasoning is often kind of, if you're doing research like I do, if you're doing experiments, you are often doing inductive reasoning. So in this particular instance, you are basically going from, you're basically starting with particular instances, and you're going to draw general conclusions from that. So inductive reasoning is basically drawing a general conclusion, maybe about people or a certain population, based on small observations. So this is what scientific research largely does. I do an experiment on maybe 20 to 30 people, and then based on the observations that I get from the experiment, I can then basically extrapolate from that small sample to a larger population and say, all people do this. So for example, in our research methods class, we basically did the levels of processing approach, where people either had to shallowly process words in terms of what they sounded like, or process what the words meant. And we found that with the general psych students, that the more deeply you process something, the better likely you are to remember it later, just like we talked about here in class. So from those 20 observations, we can say that in general, the more deeply you process something, the more likely you are to remember it. And this is going to hold even for people who are not in that sample. So we basically have particular instances and observations, and we basically draw general conclusions based on that. Now, here's the catch with inductive reasoning, and it's part of the reason why I'm very against using the word prove in scientific research. Conclusions are probable, but they're not always going to be true. So there's no guarantee that the conclusion that we actually have is correct. So here's what's kind of interesting that your book talks about that I wasn't even aware of. Information based on inductive reasoning was not considered true knowledge until the 17th century, when the scientific revolution took place. So yeah. And we do this kind of inductive reasoning all the time. You probably hang out with your friends more on the weekends than you do on the weekday. And you know that based on either observations from yourself, you tend to be busier on the weekdays than the weekends. And you may notice that with a few other people as well. So you assume that most people will be able to get together on the weekends more easily than on the weekdays. So we take these small instances of observations and we extrapolate that to the general whole. Now, deductive is different. And for a while, deductive was considered the true type of reasoning. So this is a case where you draw conclusions that are valid or they're invalid from a set of premises. So if you've ever taken logic with Dr. Roundtree, you've probably done a lot of deductive reasoning. You are given a state, or you are given statements or premises. So for example, all apples are green. This object is green. Therefore, this object is an apple. So you now I'm not saying that reasoning or that argument is valid, but that's the kind of work that you're doing when you do deductive reasoning. And your book notes that this was at the time considered the only true science, because if you have valid premises, the conclusion that follows must also be valid. So here's what's kind of interesting, and this is what really blows people up about deductive reasoning. And by blows people up, I mean it's hard to wrap your head around. So when we're talking about deductive reasoning, it is not the content that actually makes the argument valid. It is the form that the premises and the conclusion takes. So you could argue for things that are obviously not true, such as ghosts existing. And I know I'm ticking you off, some of you off right now, because I have students who very much believe that many places on this campus are haunted. you can argue that ghosts don't exist, that unicorns are always purple and stuff like that. And as long as the argument is in its proper form, it is considered a valid argument. So form matters over content. And for some of us, that's hard to wrap our heads around because content matters. So oftentimes this will use formal logic. So you're going to see this type of reasoning in philosophy. You're going to see this type of reasoning in mathematics, but it's typically not the kind of reasoning that we do. Now, I'm not saying that we don't do it. I'm saying that it's not very common, but your book gives a pretty good example of deductive reasoning. I know that Nancy is always punctual on special occasions. Today is a special occasion, so these allow me to conclude that Nancy will turn up on time today. We do this occasionally, but inductive is what we often do more. We take individual experiences and observations and basically generalize to larger situations or larger groups of people based on those smaller instances. So we're going to start by talking about inductive reasoning and hypothesis testing. Yay. Okay, so most of our reasoning is actually going to be inductive. We are constantly trying to figure out general rules and general understandings of the world around us by our own personal experiences and the limited experiences of other people around us. So we try to figure out what's generally true about the world. Now, we form hypotheses around the world. So folks, I want to be clear. I'm not talking about the kind of hypothesis testing that we do in research methods or in statistics, where we have a null hypothesis that we're trying to reject. I'm talking about any sort of hypothesis. So for example, I have the hypothesis that my travel to Chicago will go smoothly as long as I get enough sleep. These are the kind of hypotheses that we're working from. So for example, another hypothesis might be, if the food at the dining hall wasn't great today, it might be better tomorrow. You know, sometimes there are off days where none of the food is particularly appealing, but today was baked potato soup day. That helped. So when we are testing a hypothesis, when we're trying to figure something out about the world, we often refer back to the work of Karl Popper. Now, for those who don't know, Popper is very well known for his philosophy of science, how we should approach scientific testing, experimentation, and stuff like that. Popper said that if we have a hypothesis that we are trying to test, we should focus on what he called falsification. We should not seek to confirm a hypothesis, but rather we should see if the hypothesis actually holds up through falsification. So falsification is us basically trying to falsify the hypothesis, basically see if our hypothesis is false or can be false. And the idea is that if our hypothesis holds up after many attempts to render it false, it probably stands to reason that the hypothesis is true, no? So if we try to falsify it and it still holds up, it's probably true. But he said what we shouldn't do is we shouldn't try to look for evidence that confirms our hypothesis. So we should not engage in confirmation. We should engage in falsification. So if you have an idea about the world, what you should be doing is looking for evidence that your hypothesis is not correct. correct. You should not look for evidence that your hypothesis is correct. The idea is, if you can't find evidence that your hypothesis is false, it's probably pretty strong evidence that your hypothesis holds up. So we shouldn't be cherry picking data to support our point. We should be looking for anything that could potentially render our argument false, right? That's the better way to get a hypothesis. But it turns out that most of us don't do this. All right, so we're going to try something. So I'm going to give you a sequence of digits that I have organized according to a rule. I know what the rule is, you don't. So I'm going to give you a sequence of 3 digits that are organized according to a rule. Now, I want you to think about it for a second, and then what I'd like you to do is generate a set of 3 numbers and provide your rule for the set, what you think the rule is. And what I will tell you is that when you generate a sequence, I will tell you if it fits the rule or not, and then I will tell you if the rule is correct or not. So here are the digits: 2, 4, 6. Those are my digits: 2, 4, 6. So what I'd like you to do is think of a series of digits, and then I will tell you if it fits with the rule or not. And you also need to tell me what you think the rule is. And you can yell this out, by the way. Okay, somebody have an idea? Jenna, you want to try?
Can I do my numbers?
Yeah, go ahead.
All right, 8, 10, 12.
8, 10, 12, that fits the rule. What do you think the rule is?
Multiples.
Multiples of 2? That is not the rule.
Oh.
All right, it fits with the rule that I have, but it's not the rule. Bailey, what are your digits? 8, 10, 12 fits the rule.
I thought that the rule was even numbers.
Even numbers, that's not the rule. Anybody else? Yeah, Brian. 22, 24, 26, that fits the rule.
Multiples of 2 and
That's not the rule. Arena.
I don't know, this feels stupid, but 8, 10, 12, is it just add 2?
Nope. That fits the rule, but it's not my rule. Okay, anybody else? So can I tell you something, and maybe this will help you? You're all giving me things that, because I went 2, 4, 6, you're all picking things that fit with the rule that you think it is. You're doing the process of confirmation. You're trying to provide evidence to support your hypothesis. What if I told you to give me a sequence to help you figure out what the rule is through falsification? So give me a sequence that you don't think fits your rule. Yeah, Jenna.
1, 2, 3.
That fits my rule.
It does.
Yes, so now you've just learned something. So 1, 2, 3, what do you think the rule is?
What if like numbers less than 50?
That's not the rule, but 1, 2, 3 fits. See, we've just learned some new information when you don't seek to confirm. So now we know that 1, 2, 3 fits the rule. Somebody give me another sequence that might falsify the rule that you think there is.
4, 5, 6.
4, 5, 6 fits my rule.
Numbers under 10.
Nope, that's not my rule.
3, 6, 9.
3, 6, 9, that fits my rule. What's the rule though? Numbers in increasing order is correct. You know how we could have gotten that much, much faster if somebody had said 3, 2, 1, because that wouldn't fit my rule. So, but do you notice how much easier it was when you started looking for what didn't fit the rule compared to what did fit the rule? So this is called Wason's 2, 4, 6 task. And much like you, when Wason presented this sequence to people, they generated sequences that confirmed their original hypothesis. And what I found for most of you, You were all stuck in even numbered increasing digits. Once we broke out of that and we went with 1, 2, 3, that's when things started to take a turn. So people generally fail to use falsification. Most of you did not use it until I brought your attention to it. Kind of interesting, isn't it? So we're always looking for evidence that supports our point of view. We very rarely look for evidence that is against our point of view. So what we find, you would think, here's what's kind of interesting. So you would think that if people approach the situation like I did, where I'm telling you to make sequences that go against the rule, that would improve performance, but it turns out not everybody finds that. I know. Kind of weird. So by the way, one of the things that we do find, you engaged in what's called a matching bias as well. So you picked the sequences that you picked because they kind of fit the rule and they fit the way that the sequence was originally described. So I went 2, 4, 6. You matched that and went with even numbers.
I didn't.
I know you didn't, but that was after we started falsification.
Okay. Okay.
And 1, 2, 3 also didn't. But initially, those first few initial guesses were all about even numbers that increased. Right. Everybody good? Okay. So how do you get people to discover the rule? So Poltiak back in 1996 found that if you give instructions to confirm the rule, what we actually do find is that it increases the number of rules that people come up with that are not the correct answer. So when you tell people to confirm, you get more negative results. If you make a more specific rule. So here's the thing, numbers in increasing order is a really vague rule. And so Clayman and Hobb back in 1987 kind of supposed that if we gave people a more specific rule, not numbers that increase, that's really vague. But if you get a more specific rule, sometimes we find that that helps. Cherubini and colleagues back in 2005 found that people are a lot more likely to discover the rule if you give 2 examples that fit the rule rather than just 1. And all of these things can kind of work together to help people discover the rule more easily. All right, everybody good? Okay. So how do scientists test hypotheses? So inductive reasoning is often kind of the domain of research scientists. And you would think that because scientists have more training with this, that they would be less likely to engage in confirmation and they would spend more time falsifying. But Mitroff back in 1974 found that much like other human beings, scientists aren't special. There's nothing special or unique about scientists' reasoning abilities. They also spend more time confirming hypotheses and not trying to falsify their own hypotheses. So when we're talking about my research hypotheses, I'm always going to look for evidence that confirms. I am not going to look for evidence that falsifies. But like most research scientists that have their egos in the game, they don't want to falsify their own hypothesis, but they're more than happy to falsify somebody else's. And additionally, they are actually more reluctant to abandon a hypothesis, even if there's evidence that it's not correct. Now, some of you might be kind of surprised by this, but you really shouldn't be. Here's the thing. So many scientists base a lot of their research on one major hypothesis. For example, my doctoral advisor basically has the idea that we can hold about 4 things, give or take. And so here's the thing. He gets a lot of publications based on that. He gets a lot of funding money, like research money, based on that. If that hypothesis is falsified, he's going to have to find something new to research. And he's basically built his name on this. There's more commitment. Scientists have more commitment to most of their research hypotheses than you or I do. And they usually have a lot more money and their livelihood riding on that. I'm not saying it's right, but I'm saying that that's how the system works. And that leads to greater commitment to holding on to a hypothesis, even in the face of contrary evidence. And what we do find is that more than likely, if somebody doesn't get the results that they get, they will often assume that the other person did it wrong. They are more likely to attribute disconfirming evidence to measurement error or mistakes. I failed to replicate a pretty famous study, and when I mentioned that to somebody, there was the implication that I must not have followed the instructions correctly. Henceforth, I didn't get the results. I followed that study as much to the letter as I could without consulting the original authors. I'm of the opinion that if it just takes a subtle change in instructions to get very, very different results, it's probably not a very big effect or even a real one. And that's my hot take. I'm still salty about that. I will always be salty about that. Okay, so should falsification actually be a goal for scientists? And Popper makes the assumption that research and the findings from even a single study can decisively rule out a hypothesis. But true falsification doesn't just require one study to knock out a theory. It's usually going to require much, much more work. That's why it's easy to disregard the results of one study. You're like, well, it's just one study. I would need more to falsify that. Now, what's interesting is that researchers have actually looked at how teams of participants engage in falsification and confirmation in a simulated research setting. And what they actually found is that compared to simulated research with participants, scientists often have more commitment to their hypotheses. As I've mentioned, for many researchers, their hypotheses that they're trying to test are part of their life's work and probably a big part of their livelihood and their identity. If you're coming in for a research study where you're doing simulated research, you're going to have less commitment to that hypothesis. But team research, we do actually see that with simulated research, people often tend to be more open to new ideas when they're working in teams. And that's something that I've actually found very interesting in science. Science is very innovative. We find a lot of new innovations with science, but in terms of ideas, science is very traditional. They want innovation, but they don't want something so new and out there that nobody has studied it yet. They're actually very traditional. They want something new, but not so new that nobody has looked at it yet. It's kind of interesting how that works. All right. Everybody good? Okay. So now we're going to talk about deductive reasoning, and this is going to be the part that might be a little bit difficult to wrap your head around, but we are going to talk about the Wason card task, which is a part of your homework assignment that's due on Monday. All right. So when we talk about deductive reasoning, the deductive reasoning that we are often going to talk about has logical operators. So you're going to see a lot of ors, you're going to see a lot of ands, you're going to see a lot of if-then statements. So for example, if it is Friday, then Dr. Gilchrist is probably at the dining hall, or something like if and only if. So if and only if it is Friday, Dr. Gilchrist will be at lunch, those sorts of things. And the propositions that are, these statements that are made are either going to be true or false. So apples are red or apples are green. Sometimes apples are yellow. So I want to talk about a valid argument. Now, validity, according to logic and reasoning, works really differently from how we talk about validity informally. So when you bring up a good point in class, I might say, that's a valid point. That is not the same as logical validity, though. When we talk about an argument being valid, we assume that the premises are true. They may not actually be true, but we are going to take the premises as true. And the question of validity comes from the idea that the conclusions naturally follow from the premises. So validity is based on whether or not the conclusion follows from the premises if the premises are taken as true. I know, it's weird. It's all about the form of the argument. And as long as the argument follows that proper form, you can make and argue for anything that you want. So we're going to talk about a few examples because I know this looks really vague. Now, the first argument that we're going to talk about is an argument referred to as Modus Ponens. Now, the thing about Modus Ponens is I realize that I'm using this is the form that the argument looks like here. So here we have our two premises. Here we have our conclusion. So I get that this form is kind of hard to understand, so I'm going to stop share for a minute, and I'm going to write out an example of this argument on the board. So Modus Ponens is a type of argument in deductive reasoning, and it is always valid. So here's the basic form of modus ponens. If X, then Y. So that's premise number one. Premise number two is X. Therefore, Y. So if X, then Y, X, therefore Y. So we can fill in whatever we want for X and Y, and it's a valid argument. Here's an example. And folks, I had a really good lunch and I think about food a lot. So here's the example that I am going to use. If there is a line at the dining hall, Dr. Gilchrist will be upset. There is a line at the dining hall, therefore Dr. Gilchrist is upset. Do you kind of see how that works? So I'm basically saying, if this thing happens, then this thing's gonna happen. This thing happened, therefore that thing's gonna happen. So somebody fill in the blanks and make another modus ponens argument for me. Somebody wanna try? It can be whatever you want. Bailey.
If it's a long day, then I'm tired, and then
It's a long day.
therefore I am tired.
Yep. Mhm. Okay. If I have pancakes on Friday, then unicorns must exist. I had pancakes on Friday, therefore unicorns exist. So again, not about the content, all about the form. As long as it follows this form, it is a valid deductive argument. Kind of cool, huh? Also very difficult to wrap your head around. I took logic in college. Yes, here we go. Put one on your Dr. Gilchrist bingo card of things that she says often. I was a philosophy minor in college. I was required to have a minor. And I loved my intro to philosophy class so much that I just decided to minor in it. And one of the things that I was required to do was take a class in logic. Best class I ever took. It's actually come in handy for a lot of the computer programming that I do for experiments, because it uses a lot of these logical operators and it kind of teaches you to think this way. It's kind of neat. Okay, so that is the basic modus ponens argument. So if you are thinking about taking my final, write down that that's a modus ponens argument, because I am going to refer to modus ponens. You need to know specifically which one that is. So if you're thinking about taking the final, write it down. If you are good and you don't need my final, I mean, you should still take good notes, but I can't force you. All right, everybody good? Okay. So now we're going to talk about another argument. This one is called Modus Tollens. So I'm again going to stop share here. So this basically says if P, then Q. This little symbol here means not. That means not. So Modus Tollens follows this argument. If X, then Y. Not Y, therefore not X. That's modus tollens. So if X, then Y, not Y, therefore not X. So going back to my pancakes example, if I have pancakes on Friday, then unicorns exist. Unicorns don't exist. Therefore, I didn't have pancakes on Friday. So I know that that sounds really silly, but if we take all of those premises as true, the conclusion, therefore, I did not have pancakes on Friday, follows naturally from all of the premises. Modus tollens is another valid argument. So again, you can fill in whatever you want, and it will still be a valid argument. Does somebody want to give this one a try? Anybody? You can fill in whatever you want. Ooh, I got it. If Dr. Gilchrist is a nice person, then I will pass this class. I did not pass this class. Therefore, Dr. Gilchrist is not nice. Not true, but it fits the argument, so it is valid. If all of the premises are taken as true, the conclusion follows naturally from the premises. You are going to pass this class, by the way. Everybody's passing. Like, everybody's going to be fine. All right, everybody good? All right, so now we're going to talk about arguments that look like they're valid, but they're not. So we're going to talk about what is called affirmation of the consequent. So really quick, I want to go back to Modus Ponens for a bit. So if X, then Y, X, therefore Y. So when we talk about this if-then statement, the X here is what is called the antecedent. This is the precursor to what happens. What's Y here is called the consequent. So we have antecedent and we have the consequent. So we have an argument called affirmation of the consequent. This is not a valid argument form, but let me show you what it looks like. So we have if X, then Y. Y, therefore X. That is affirmation of the consequent, and even though it looks valid, it isn't. So I'm about to give you an example that I think you'll appreciate. So while watching Intervention, all crackheads love Mountain Dew. Hey, I love Mountain Dew. Exactly. So let's go into what this argument means. So we're going, if you are a crackhead, you love Mountain Dew. So the antecedent is if you are a crackhead. I got this off of the internet, by the way, and I thought you would appreciate it because, well, I love Mountain Dew and I'm also not a crackhead. So if you love Mountain Dew, or if you are a crackhead, then you love Mountain Dew. You love Mountain Dew, therefore you're a crackhead. Can you think of a lot of instances of people who love Mountain Dew that aren't crackheads? This is specifically saying that if you are a crackhead, you must love Mountain Dew. But it doesn't say anything about people who love Mountain Dew and are not crackheads. This is specifically about crackheads. So this is affirmation of the consequent. The conclusion does not naturally follow from the premises. Most people consider this valid and it isn't. So this is affirmation of the consequent. If X, then Y, Y, therefore X. It is not valid. Because you can think of many instances of people who are not crackheads that love Mountain Dew. I am one of them. And I'm offended by this argument. That's why I shared it with you. So the next one that is also not valid is what is called denial of the antecedent. So remember that this is the antecedent, this is the consequent. So denial of the antecedent takes this form. If X, then Y. Not X, therefore not Y. This is also not a valid form. So here's the example. If you are a ski instructor, then you have a job. You are not a ski instructor. Therefore, you do not have a job. So again, this is a case where the conclusion does not follow from the premises. This is only saying that if, and this is not saying if and only if you are a ski instructor, will you have a job. It's saying if you work as a ski instructor, that is your job. It is not saying anything about the job status of anybody who is not a ski instructor. It is not telling us that only ski instructors have jobs. So we take this if, and we sometimes turn it into an if and only if, implying that ski instructors are the only ones that have jobs. And that's not what's being said here. It's being said, if you work as a ski instructor, that's your job. It's not saying if you work as a ski instructor, you are the only one with a job. So this is denial of the antecedent. Again, this is one that people think is valid, but it's not. So again, denial of the antecedent is if X, then Y, not X, therefore not Y. I would never be a ski instructor. I can't even go on the bunny slope without being terrified and waving my arms around when I'm supposed to keep my poles in the ice. I have been skiing. I don't like the idea of falling downhill with nobody to catch me. Okay, so here's something that's kind of interesting. So what you're looking at are the percentages of participants for a variety of different arguments. And what you can kind of see is, in general, most people are able to correctly guess that modus ponens is a valid form. Where most people start to have trouble is with modus tollens. Modus tollens is basically if X, then Y, not Y, therefore not X. People start to have trouble with that. Interestingly, people are pretty good at figuring out that the denial of the antecedent is not valid, but modus tollens, people think it's invalid when it's not. And affirmation of the consequent is also kind of hard for people to figure out. But most of us are pretty good recognizing that modus ponens is valid. I don't think I'm going to have time for the Wason argument, so the Wason card test. So here's what I'm going to do. I'm going to move the deadline for your homework all the way to November 29th, because I'm going to give you a link for you to watch on Monday that will cover the Wason task for your homework assignment, and we'll have time to work on it then. You don't have any homework assignments due on the week of the 29th, so I don't mind assigning it later. So I will put that up, and I'll send you a link to the lecture that you should watch on Monday. Okay? Sound pretty good? Folks, have a wonderful weekend. I will see you when you come back from break. Don't forget to take your quiz. I thought we'd have time. We're so close. We were like 2 slides away, but I don't want to hold the class over. So I'll send you the link to where we talk about it.